Hello. We are looking at homework 5.2, and we're talking about the single cycle. And I want to show you the solution for one of the questions because it may be difficult to start thinking in this way. So we have a question here, question 5, which is a new instruction has been added to the Mips chip called BEQAL, or equal, maybe you want to call it. Um, RSRT label. It is of type I. Okay, well, that makes sense, type I, because there's two registers and a label, which is going to be 16 bits of immediate value. This instruction jumps to the label as if RS and RT. Well, that's just like BEQ so far. But in addition, if the jump is in fact executed, the return to location P plus 4 is stored in RA. In other words, the value of PC plus 4 is, which is the return to location, where do we return to, if we want to return to, is stored in RA. The address of the jump to the location will be calculated in the same way as calculated with BEQ. So the BEQ is the same as it was, the jumping, but the only addition is that we're going to store PC plus 4 into the RA register. Update the hardware of the single cycle MIPS so that it will support this new instruction. Use the solution that requires the minimum number of changes and explain your changes. What will be the values and the control lines for the new instructions? So we have to have new control lines to handle this. So our controller will have to be increased. And we're going to have to add something to the single cycle. So let's do that. How are we going to do that? So first of all, let's go here. View, slideshow, make it bigger. And here is our diagram. And as we discussed in class, we know that the BEQ uses the ALU to compare the RA to the RS and the RT. And they're going to come in here, we're going to subtract them, we're going to get to 0. We're going to, if it's a branch command, this will be lit. And if they're both 1, then we'll put a 1 over here, and the value that will be sent to the PC will not be PC plus 4, but will be the shift left of the immediate added to the PC plus 4. And that will come through this mux. It'll also get through this mux because this will be set to 0, and it'll come back to the PC. That's how we explain the PC. Now, all that's going to remain the same. But now we have to also write to RA. Now, what is RA? RA is a register. It's one of the 32 registers that you could write to. And who does the writing to it? Well, the register file. So we're going to need to get the PC plus 4 to come down to the write data field. Now, the write data field normally is coming from either the addition here, which we don't want, or the memory here we don't want. We need it to come now from the PC. Now, there's lots of ways of doing this, but, oh, sorry. But the simplest way is to take the PC plus 4, which we've got over here, and bring it directly to this place. So let's do that. And I can go like this, PC plus 4, and I'll just bring it right here to the right data. But I'm not going to go straight into the right data yet because I got a competitor. He also wants to go to the right data. So I'm going to have to choose one of them. You know, whenever I'm doing choose, I'm going to have a mux, multiplexer. Let's draw a mux. And this old line here, maybe I'll change the color for black. Here, for the old line, he is going, instead of going straight in, because he needs to make way for me, so he's going to come in, he's going to continue going, but he's going to come into this mux here. And now I can choose which one do I want to be in the right data. So, well, first let's add another arrow. This we sort of have it here, but let's draw it. Draw an arrow here. It's going in. Okay, that is going in there to write data. And let's put a 0 over here and a 1 over here. And we need a control line. So let's do that in red because that's just so you can see better. Control line. Let's put a new control line. Let's come out here. And oh, actually, I should have labeled it 0 and 1, and the 1 and 0 instead of 0 and 1, but it doesn't matter. Okay, this control line is going to come here and be the control line for this. All right, so in our command, if we want to do our command, this new command, BEQL, we're going to have to take the PC+4 and stick it into this write data. So this will be 0 on this line if we want to do our command. So we'll call this, what should we call this control line? We can call it BE here, text. Let's call it BEQAL. Okay. Okay, so that's the line BEQAL. Sorry, it's a bit messy. I should have put part left. But this is and it's a 0 on this line if I want to do my command. And if I don't want to do my command, I want to do any other command, it'll be a 1 on this line to go back to the normal old state. That's what this is. Okay, so far we have a way for the controller to tell if the command is a BEQL, put a 0 on this line and write to the write data, the PEQ. But where do we write it to? We write it to a particular register. Which register? The RA. But the RA is not in the command. The command just has the RS. It's just a normal B. It looks like a normal BEQ, which means it has an RS, an RT, and where to jump to. Where there's no RA written in the command. So we have to just hard code it to tell it go right to the RA. So in order to do that, I don't know about a space over here. Normally I'd write it over here, but I'll write over here. Well, let's see. You know what? Let's escape from this and let's see the green card. Green card is your friend. Let's say MIPS. Oh, these writings are going to be in the way a little bit. MIPS green card PDF. And here, let's see what this shows us. Let's just see. I want to know what number the RA is. It's a little small. So if I go down here, RA, this is in like Greek or something. It's interesting in Greek, but I don't care. It's Greek because it tells me that the RA is 31, is register 31. Okay, so that's all I need. I just need to know what number it is, register 31. So what we're going to do is go back to our drawing and do view slideshow. And we want on this line to be a 31. So here, let's oh, I wrote 32. That's a mistake. Yeah, I'm so used to writing 32. It's a nice number. Erase that. Okay, and let me try that again. 31. 31, and we've got to have a line coming in. So let's draw that in red here. So this line is coming into here. But that means that our mux has now got 3 inputs. So if this was 0 and this is 1, well, you know what? I don't like the way I drew that. Let's get rid of that. Draw it again. Let's say the 31 comes in down here. And let's make the mux has to be made bigger because the mux only has the possibility of 2 inputs. So let's make it bigger. Here I'm extending the mux a little bit. And we're calling this 2. Sorry for getting a little bit messy. There's a 2 here. And this 31 is coming in, it's hard-coded. There's like a 31 sitting here. And it's hard, just like we had a 4. And you say, well, I didn't know you could just draw 31. Well, actually, you did, because look, there's a 4 over here. See that 4? You understood that I could just write a 4 here and put it in. So I can write a 31 here and put it into this mux. Now this mux has a control line, which we called the register destination one, right? This was already coming in over here, and it could either be 0 or 1. Now we're going to have to add, instead of it being a single line, it's going to have to be 2 lines. So let's change it and write a 2. This is how you symbolize that it's 2 lines. You write a 2 with a slash here. See, like, do we have that in any other place here? Yeah, here. See, it says 32. See, it says 16 going in with a slash and 16 bits, and a slash and 32 bits going out. That's how we indicate that how many bits are on the line. If we don't write that, then it's just 1 bit usually, except, you know, there's no 100% consistency here. For example, the ALU op is 2 lines, even though they didn't write it, but so they made it thicker. But we're going to use this notation, the /6. So we're going to write /2 here and indicate that maybe I wrote the slash in the wrong direction, but it doesn't matter. /2, and that's just saying that there's 2 lines. Now, what we're going to have to write in our answer is that in order to, if it's a BEQ command, BEQ, then this register will still be either, will still be what it was before, which I think was a don't care because we're not actually writing anything to the register file. In a normal BEQ, we don't write to a register file. So this was a don't care. We didn't care what we put here because we're not writing anything. But now, and because register write was 0, now when we do this command, we have to indicate that register write is going to be 1, not 0. Let's put a little there. It's going to be a 1, not a 0, because we are writing. The BEQ line will be 0 and not 1. And in all other commands, it'll be 1. But in our new command, it'll be 0. And we're going to have to write that we added another line to the register destination, and that for all other commands, it'll be what it was, either 0 or 1. But for our new command, it'll be 2, which is, right, it'll be the value 2 as the control line. So if it's our command, we're going to put a 2 over here onto this mux. This mux has been expanded and allows the 31 to come in. And if we write 2, then that'll let it pass through, and that'll be the location to write. Because it's true that we have the data to write, which is the PC plus 4, but we have to write it to the right place, which we said was RA, which is 31. So so in addition to the BEQ being set to 0, which is for this mux over here, the register destination will be set to 2 to indicate, this 2 doesn't mean that we're setting it to 2. I mean, I could write, let's write another 2 over here. In other words, it'll be set to 2 Where's the line coming in? This line will be set to 2 when we're doing our command. When we're doing our command, these 2 digits will be set to 1, 0, which is the value 2, to indicate let the value 31 pass through into register write. And also we have to put a 0 on this new mux. We can label the mux like mux A or mux B or whatever we're going to call it. And this new mux will be, so that's the solution for that question. I think once you see that solution, you'll understand how to do the other ones that require changes in the diagram.